basic fundamentals of Digital Product Passport and what I owe. This is kind of a short YouTube series where we will go through different type of things with our platform at What I Owe, and we will also show you some of the technology behind, and I hope you get some insights from this channel. So this is actually part of our training program, but I will use this presentation still to go through the whole fundamentals of DPPs. So in this part, we will actually look at different identifiers, also called data carriers. We will look a little bit short about data repositories and how they interact with the DPP. And it's pretty basic. So there will be more episodes later where we will go much deeper into the tech. So let's start with what is Digital Product Passport. There is so many ways to describe it, and I think there's a lot of people out there who's actually not involved in Surpass 2 and the European Union project that make their own perception and interpretation of what it is. So basically, it's a digital twin of a product with all its different type of life cycle information. And to retrieve this information, we need a computer of some kind. We need either a microcontroller, we need an iPhone or any kind of a Google Android phone, or any kind of laptop computer to fetch the data, because the data is actually not on the product in the DPP. The DPP is more like a token on a blockchain. It's more of a URL link that links to the information. And this is also done through an identifier where we will show you how that works. DPP can also be different levels. I will come back to that briefly. And also DPPs can be bidirectional. So there's also a way for the actual data carrier or to be more advanced and more intelligent, and that can then produce information like it could be temperature, humidity, and these kind of things. So first of all, let's look at the information management for physical assets. So physical assets today can be anything you can imagine in the world. There's a lot of information about these assets. So how to make the montage and assembly, how to disassembly, how to recycle, where was it manufactured, what's the LCA, what's the energy level according to EPREL, etc., support information and so on. And what you see on the screen is basically a simple overview of potential information assets a DPP can carry. And all this information obviously is maintained by the manufacturer in the cloud. So there is also a way for these DPPs to be alive. They can be updated. So if there is a new energy declaration, depending on some new regulations, the DPP is not dead. It's absolutely alive, and the link is dynamic. So that also means that if there is a change, there is some new spare parts, or they change the support channels or something like that, all this information is live, which is, of course, really nice when you look at the potential 20, 30 years of life for a particular product, that if there is updates and changes, you obviously want to have these changes if you are an owner of the actual product. So let's continue and let's talk about identifications. So when it's identifications or data carriers, at What I Owe, we work with 4 different parallel tracks. There is, of course, more different type of variations on these, like RFID is a very wide area. But let's look first on the most basic one is obviously only to use these QR codes. Super simple. You can put them on labels, and you have seen them probably during COVID. Every single menu in a restaurant was starting to use these, so they didn't need to have a paper copy. There is pros and cons. They are simple, they are easy, but it's also easy, of course, if you see them, you can peel them off. If they're printed on paper, obviously water will make them go away, and so on. So there is good news and bad news with these. Very easy to read. Obviously, you use the camera on the on your phone, and you can read them. So this is one of the most common cheap carriers, and I think when it comes to generic DPPs, in many senses for logistics and things and shop checkouts and stuff, this will be used. Textiles is an obvious area where we will see a lot of QR codes. A more advanced way, and where a lot of our focus at What.io is of course this little buddy here. This is the NFC chip. It's a part of RFID, so radio frequent identification. NFC stands for near field communication, and the beauty is that these particular ones, they have a small memory, 144 bytes, because this is an NTAG 213. These are the same ISO standard 14443A that's used in basically all your credit cards, so you're actually already using these. The good news is also that this standard is used by all the mobile phone operators like Apple and Google. These OS can read just by tapping on these without any app whatsoever. They will just recognize there is a URL on the NFC tag, and you will immediately get access to the product's DPP and information. They are cheap to manufacture, and they don't cost much to buy from different vendors. We have 3 different factories we work with, and we can get them in different size and shapes. And the biggest part of it is, of course, the antenna. So it depends a little bit what material you are using. If you're using materials which are more of a metal type, you have to be careful because they will actually block the antenna signal. But for rubber, plastic, paper, cardboard, these kind of things, that's absolutely no problem. And in 3D printing, which is one of our specialities at What.io, we can kind of put this inside the material, inside the plastic, down to approximately 15 millimeters, and it still works amazingly. The other technology is the NFC RFID EEPROM. This is much more advanced technology. And I will come back a little bit later to show you how this can work. But these are basically on this board. You can see this one here. This is actually a device which is an interactive NFC tag. It means that it can also carry additional information dynamically. So if this tag is in an environment where you measure temperature, for instance, it's possible for the DPP to actually be sending data, continuous data about the temperature where the DPP resides. It could be for products that is very temperature sensitive, and yeah, you need to do that on different levels. So these can be read the same way with a phone or with a computer. And you can simply tap on them. So they work exactly like an NFC tag, but it can be reprogrammed by a microcontroller interactively, and you can have additional information on them. The fourth one is the AI vision. This is, of course, with the big kind of push on artificial intelligence. We have some research where we built GPTs, and we teach them. We use the DPP data to teach the AI model how the product looked like and the data and where it can find the data. And for the generic level, the so-called model level of DPP for simple products, that's still kind of unique in shape and feel, it actually works really, really well. The beauty with AI vision is obviously that you don't need to put anything on the product or inside the product. It's the AI that it will interpret things. On the other side, it's on the granular detail level, it fails, obviously, because it will not understand the uniqueness of products and so on. But we will come more back to that. So one aspect which is really, really important when we talk about DPPs is that there is 2 kind of ways to read and get the information. One is a human versus machine, basically. So humans will, of course, mainly use their phones, and you will do that by scanning a QR code, tapping on an NFC, and you're getting the product sheets. We're also working at What.io with AI in that sense, so you can also get a kind of a chatbot where you can chat with a DPP and ask questions about how to install something, how to modify something. But mainly this is then humans reading the data. If we talk about machines, we talk more about microcontrollers. And when microcontroller reads and interact, they, of course, use something called API. And the API gives you much more detailed data than the human reading of a PDF or a website or a product data sheet. And that data can then be acted upon depending on what it finds in the DPP. And machines will be typically logistics, security systems, automatic programming in the factory of the DPPs, etc. This is where you will see more and more machine writing and machine learning in the DPP section. So that was the data carrier. So let's have a look at the three levels of detail of the DPP. So we call them model, batch, and unique fabricated item. And let's start from the bottom, actually. So unique fabricated item, this is where you can basically say that every single product get its absolute unique identity when it's manufactured and leaves the factory to customers. Every product is made and will be created in a unique manner. So it's almost like a social security number, completely unique. The beauty with that is that it will be traceable. You can actually trace an individual item. You can have ownership, you can have authentication and these kind of things because you actually know which product is which. And we also have a unique token ID, which we do when we program these NFC tags at the factory for different type of brands, and they get their uniqueness and connected to a unique DPP in our cloud solution. We also add a token, and this is a US patent we have, how we write this token to the chip. And we do all that so it will be harder to counterfeit these chips, and you can be sure that you have the original item in front of you. The middle level is batch, product level. This is more simple. You can use QR codes, you can use NFC also. You do know where the product is manufactured, what week it's manufactured, what batch it can be using. And you could even have with a material passport and our material database, you can know actually which material batch the actual product was made of. That will be very popular, I would imagine. For many, that will be the standard, depending, obviously, what kind of product or area you're in. And then we have the simplest form, which is called model. This is when the DPP basically, it looks as the same DPP for any product. It doesn't differentiate the DPP when it's manufactured, where it's manufactured, when. It's mainly will be used for assembly instructions, support instructions, and simplicity really to the model level. It can even be that you have a model level DPP outside of your box, and then inside a product there is a unique fabricated item DPP. So you can even have a mix of both if you would like that. So let's have a look at how you can read these. When we look at human reading, anyone can basically read this. That's the whole intention, that you can learn more about the product before you purchase it, or you can help someone to assemble it by just getting the instructions, for instance. And that can be done with your simple iPhone, with a camera. You can do it completely anonymous. You don't need to tell who you are. You don't need to download an app. You don't need a login or installation. No cookies or data is stored, so there's no GDPR. And you use your standard camera basically on your phone. It's as easy as scanning a menu card on a restaurant. So this simplest version is called the model, and you read it completely anonymously. So if you go one level deeper, you want to tap on a certain NFC tag and not using the camera, you go into the NFC field. You can still do the same. you can still run model battery unique item, and you still don't need an app. Our solution is based on full, simple, easy usage. And you can be fully anonymous. You don't need to log in somewhere. You don't need to tell who you are. You can tap on the product and you can get all the basic information, what the manufacturers want you to know, without you actually explaining and telling who you are. So there's no need of any pre registration or anything like that. However, if you go into the professional field of repair, service, all this kind of maintenance and management, and maybe even recycling and other type of information about manufacturing the spare parts and these kind of things, obviously that can be a requirement, and then you will need to download the app, the What.io app or some other app for reading the DPP, and it will actually check that you have the credentials to get this information. So you can also develop custom apps to our solution. We are already fully API. So you can also make other kind of user interactions. There is also opportunity, of course, to make it like a log. So if you do like repair as a professional service manager, you can do the repair, and then through the DPP, you can actually tell that, okay, this is the place, this is the date, I changed the filter on this HVAC unit, and that also need to be signed off by the person actually on the app. That's why you need to be registered. This data will then be saved to that particular DPP in the cloud. So you have like a bi-directional item you can do. And that's, of course, pretty amazing stuff if you think about maintenance of products in buildings and things like that. Let's go over to the machines. So machine reading will be very, very big in the field of DPP. That use means that you will use some kind of microcontroller. And a microcontroller today can be like this in the back. Here is a small Arduino unit. It's a $25 computer, runs in C++. And this can be connected to a lot of different devices. It can read and write NFCs. It can have these EEPROM dynamic NFC tags. And of course, it can read QR codes. And that one is actually not fetching the web-based DPP. It's using API. So it can also decide that I'm only interested in reading some specific data set in the DPP data because of different reasons, for logistics or for reporting or for anything else. And that's something that's done. So this is actually one of our Dolores boards, which is actually reading QR codes and also simulating NFC tags in our exploration module. So this is one of the neat little hardware devices we develop at What.io for everybody to be able to customize and develop. Then you can have more advanced NFC. So Incendo is a device which the cases are fully 3D printed. It means also that you can build your own and design your own casing for this device. It's simple. It has a task of either reading automatically on different types, like in industrial environments where you cannot use the mobile phones for different reasons and so on. Or one thing which is super important is that it can automatically program the NFCs in the factory, sends and communicate through API and Wi-Fi, obviously, with the What.io cloud, and it will actually generate the DPPs and talk back and forth with the cloud to build up this relationship and get that unique ID, get that token, but it does it without any human interaction, and it just needs to sense that there is a small tag coming its way, and when that tag is within reach, approximately 4 centimeters or 40 millimeters, or an inch, 1.5 inch, it will automatically burn the chip and basically baptize it and make the relationship and the connection with the What.io cloud. These are something we develop more and more in our solution, and we will run these devices as a part of the whole solution. And you you will be able to have multiple devices since they are very cheap, very easy to maintain and set up. So the more advanced technologies, I have a whole episode about Dolores. So Dolores is basically our development system. This is typically for scientists, researchers, product developers to learn about DPP. So this is a 3D printed box. It has the NFC tag, it's a speaker, microphone, and it's actually fully compatible with all the different boards, all standardized boards. So it's basically thought as an exploration module where you can use it to learn how to build your own boards or use the boards we have developed and learn how to integrate and develop and talk. And one of the things we're looking at that Dolores will be a part of is actually using 3 different APIs. So it will use the What.io API for everything DPP, everything which has to do with data. It will use the ChatGPT to teach it either with AI vision, or it will just use it as a kind of a talking head or a chatbot. And then, of course, we use the Google text-to-speech, speech-to-text. So it will enable you to actually build and interact with the DPPs, program them in the right way, or ask questions about the DPP. And then basically the AI will use all its knowledge and data from What.io because it knows exactly what product it has in front of you. And then you can actually talk to the product. So think about Dolores as a development platform. It's not a finished product that you actually put out like Incendo. Incendo is something you can put straight out into the factory and use it today. Dolores is something where you use it as an exploration tool. However, all these boards are standardized, so they could both work in the Dolores module, but you could also build your own casing. And we will also build a lot of different cases with 3D printing, of course, using recycled materials and manufacture them locally. And these devices are more and more available. I think we will have the first Incendo NFC device for Dolores ready now. And this will be launched somewhere in March in 2025. And then you can actually start to play around and start to produce massive amounts of intelligent, unique NFC tags that you can integrate into your production. So that was basically it. There is obviously ways to do this in different ways, but this is the way we at What.io look at DPP. And I hope this just gave you some kind of fundamental understanding of data carriers, different type of levels of information, and also human reading with iPhone versus machine reading. So we will go deeper in other episodes, but this was everything I had for you today. So thank you very much.